Okay, today what we're looking at in 4.2 is finding angles using trigonometry. So I can find the angles in a right triangle using the primary trig ratios. Okay, so first of all, if you know two sides in a right triangle, you can determine either of the non-right angles by setting up ratios. Okay, and so that's what's kind of cool about it. So just remember, and we're using primary trig ratios, which stand for, I'm sure you all remember, sine. Remember, it's not sin, it's sine, cosine, and tangent. So sine, so if they give me the opposite and hypotenuse sides, I can use sine. If they give me the adjacent and hypotenuse sides, I can use cosine. Or if they give me the opposite and adjacent sides, I can use the tangent ratios. Okay, now to do this, obviously my calculator is going to be very important to me. So to tell the calculator that you are inputting the ratio and you want it to give you the angle, you need to use the inverse sine, cosine, and tangent buttons. What it looks like is sine with a little -1 in the exponent area, and it's pronounced the sine inverse. Now, depending on the calculator you have, you might have to press second, inverse, or a shift key whenever you have, in other words, whatever you have in your calculator in order to find it. So for instance, if I'm using the graphing calculator and I want it to find the inverse of a sine, notice on a graphing calculator it literally does sine to the power of -1, and I could put 25 in there and it actually would, oops, it would actually give me um, the number that I'm after. I should need a decimal in there and it didn't put a decimal. It would actually give me the angle. So that's how I do it on this calculator. But if I pull up a different calculator, such as this other one that's on the computer, if I wanted to find what that was, that decimal to 8 or whatever it was, as an inverse sine, I have to, in this calculator, I have to put the decimal part in first, then I have to say inverse sine. And I get it in both cases the same answer. However, the keystrokes, what I enter first and what I push, are different. Okay, so make sure you know how your calculator works. Okay, so the first thing we're going to do is find the indicated angle in the following triangles. So same thing that worked in our last questions. I want to circle my theta. Everything's labeled according to that. So directly over, across from it is opposite. Here's my hypotenuse, which means this is adjacent. So again, what I can do is I can use SOHCAHTOA and see which one I need to use. So SOHCAHTOA, the two sides I'm given are adjacent and opposite. So you can see the one I'm going to use in this case is TOA. So that is tan of a theta equals opposite over adjacent, which equals, in this case, remember I'm finding theta, equals opposite, which is 7, over 12. Now what I need to do is, in most cases I tell students to change that to a decimal. So it's going to be 0 decimal something, and we're going to bring up a calculator. And again, it doesn't matter which one you bring up. Actually, I think the graphing one is easier to see when I'm doing this. So 7 divided by 12. Oops, too many divided by 12. Obviously, I can't hit the right buttons. Okay, decimal 583, repeating. Now remember, I need 4 decimal places because this is a ratio. So decimal 5, 8, 3, 3. So the ratio when I divide those two sides is this decimal. So if I want to find theta, it's going to equal the tan inverse of that number. And when I do that on my graphing calculator or any other calculator, I end up with 30.3, and now that is a degree. Okay, so let's go on to the next question. I'm just going to switch colors just to make life a little bit more colorful, because it is. Okay, so here is my theta. Directly across from it is opposite. Across from the right angle is hypotenuse, so that makes this adjacent. So now what I'm going to do, again, I'm going to write SOHCAHTOA so that there is no mistaking in what I am going to have for my answer. Okay, I'm back. You probably didn't even know that I was gone. Okay, so there's ka, and now I need the toa. And the sides I have opposite, and I have hypotenuse. So you can see in this case, I'm going to use the sine. So I'm going to write down its little mini formula. So sine of a theta equals the opposite side over the hypotenuse. In this case, the opposite is 6. My hypotenuse is 14. Again, I take my calculator and I'm actually going to change it into a decimal. And I'll use this one this time. Notice I just exchange calculator's a calculator, right? 6 divided by 14. So decimal 4286, 4286. And now I need to take my calculator, and theta is going to equal the sine inverse of that number. And again, it depends how your calculator works, which way you have to do it. If I use the graphing calculator, notice I just switch back and forth because I have no problems with that. So, and this one is second sine, decimal 4286, and I end up with 25.4 degrees. Okay, our last question on this page. Again, what I'm going to do is I'm going to circle the angle that they gave me. So in this case, it is, here is what I need to find. Directly across from it is opposite, across from the right angle is hypotenuse, and this is adjacent. Again, I can use SOHCAHTOA, and I bet it is ka because I haven't used that one yet. Okay, so I have the hypotenuse and I have the adjacent side. So you can see I'm going to use the cos, write down its formula. Cos of a theta equals adjacent over hypotenuse, which equals adjacent 3.2 over our hypotenuse, which is 9.8. Again, we're going to turn that into a decimal. And we'll just bring up, we'll just bring up this calculator. So 3.2 divided by 9.8 equals decimal 3265. 3265, and that's a decimal. And now to find my theta, I need to tell my calculator to take the cos inverse of the ratio to get my final answer. And when I do that, that's a 5 by the way, it's going to equal 70, and it's going to round to 70.9 degrees. Okay, so those steps follow through for all of them. Now we're going to do one example that's a word question, so I'm going to stop it. It won't be as nearly as long as this last question.